Why would one drilling rig sit on solid ground, another stand on giant legs above the sea, and a third float in deep water? The fundamental functions of a rotary drilling rig remain largely unchanged, though their capabilities have expanded significantly to meet modern operational demands. At their core, these rigs must transmit torque to a drill bit, circulate drilling fluid down the drill string and up the annulus, and safely control the subsurface pressures that continuously increase as the well depth grows. Because hydrocarbons are found across all continents and sedimentary basins, drilling takes place in practically every conceivable surface environment on Earth, broadly categorized as either onshore or offshore. As drilling progresses deeper into the Earth, operations become inherently more difficult, much like dangling a string of drinking straws from a 75-story building to represent a 4,500-meter drill pipe. Managing these increasing subsurface pressures is a primary focus of the entire drilling process. Onshore, the operational environments vary widely from extreme Arctic permafrost to scorching deserts and dense jungles. A major logistical challenge for any land rig is moving it from one location to another, whether simply shifting to a nearby slot on the drilling pad or undertaking an intercontinental rig move. Heavy land rigs, which are capable of reaching depths beyond 9,000 meters, typically utilize a solid A-frame mast constructed from prefabricated sections that is assembled on the ground and hoisted vertically using the drawworks. Lighter land rigs may employ similar telescopic masts raised in two steps, while very light well-servicing rigs might be entirely integrated onto a single road-going truck. The specific operating environment heavily dictates the rig's design. For instance, Arctic rigs must endure severe cold that negatively affects the impact resistance of steel and requires systems to prevent fluids from freezing, whereas desert rigs must generate sufficient power to offset engine inefficiencies in ambient temperatures exceeding 50 degrees Celsius. In highly remote or inaccessible areas, operators may utilize a heli-rig designed so that every single component can be safely transported and assembled using a heavy-lift helicopter. When drilling operations transition offshore, adverse weather and water depth become the two most significant challenges. In extreme shallow coastal waters or swamps, operators might construct man-made islands or rely on barge rigs. A barge rig is a float-bottomed vessel with a shallow draft that is towed to the site, where its hull is then flooded so it rests securely on the seabed, typically operating in water depths up to 4 meters or up to 6 meters for posted barges. As water deepens to between 10 and 200 meters, self-elevating jackup rigs become the preferred choice. These units are towed to the location with their legs raised high above the deck. Once in position, their legs, usually 3, are jacked down to the seabed, elevating the entire deck and cantilevered drill floor safely above the waves. Because their high center of gravity makes them cumbersome and vulnerable to leg damage during transport, jackups are sometimes moved over long distances on the back of specialized heavy-lift vessels. For even greater water depth, floating drilling units such as semi-submersibles and drill ships are required. A semi-submersible rig consists of a floating deck supported by submerged pontoons that are heavily ballasted to provide a low center of gravity and excellent stability below the wave action. Depending on the water depth, these rigs are held precisely on station either by complex anchoring systems or by computer-controlled dynamic positioning thrusters. Drill ships, which are self-propelled vessels, are deployed for extreme deep-water operations. Equipped with a central drilling slot known as a moon pool, these ships provide vast storage capacities, making them ideal for continuous operations in remote locations where they maintain their station using dynamic positioning propellers. For long-term field development, fixed platform rigs are often utilized. Here, the derrick and substructure skid across a permanent steel or concrete platform to drill up to 20 or more wells before the rig is dismantled, when the production phase begins. In areas with benign weather, like the Far East, tender assist drilling units are often paired with these platforms, housing the heavy mud pumps, generators, and bulk storage of the platform to dramatically reduce space and weight requirements on the fixed structure. Across all these varied environments, modern rig design is largely driven by 3 key factors: Automation, drilling efficiency, and environmental impact. Historically hazardous rig floors are being transformed by automation, taking personnel out of harm's way by replacing manual pipe makeup with iron roughnecks, automated pipe handling systems, and iron derrickmen. To justify soaring operational costs, particularly in deep-water environments where day rates can exceed $1 million, modern rigs focus heavily on maximizing efficiency through dual activity centers and offline stand makeup, allowing multiple operations to occur simultaneously. Concurrently, environmental protections are becoming stricter. Land rigs are increasingly equipped with noise-dampening baffles or fully enclosed derricks to accommodate encroaching residential areas. While rigorous zero-discharge mandates onshore and offshore necessitate advanced cuttings recovery and drying packages to manage spent drilling fluids. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more content on the oil and gas industry. Thank you for watching and see you next time on Better Learn.